Okay, what if I have a case where I roll a ball off at 5 meters per second, another ball is going to roll off at 2 meters per second, and the third ball is just going to be dropped at the same time. So the question is, which one's going to hit the ground first? I'm just going to draw one little thing here for you for now. Okay, so you thought about it? Okay, so I got 3 of them. This is a kind of a cliff they're going over, or an edge. And that's my question here. This guy's going at 5, 2, and this guy's just being dropped, so his 0 meters per second. So I hope you notice that if we were to make, I'm going to make, just to kind of show you my point here, a table for all 3 of these motions. I'll call this V1, or I'll just call it 1Y, 2Y, and 3Y. Okay, so, and this is my X. And my X, I've got V1 is 5 meters per second, V2 is 2 meters per second, and V3 is 0 meters per second. And in my Y direction, I put down, let's make this table 1.5 meters. So negative 1.5 meters. Delta Y for this is also going to be negative 1.5 meters, of course. And for that one's also be negative 1.5 meters. Okay. Acceleration, negative 9.8, negative 9.8, negative 9.8. And so we say, okay, but and VI is 0 over here because he's going up, and also 0 for him, and also 0 for him. Wait a second, they're all the same, which means anything I calculate in terms of VF in the Y direction, how would that work change? How about my delta X? How would that change? Now this one depends on time, and so does this. So let's figure out the time first, and you see the time will be the same for all of them. And that's the key thing I'm trying to draw to kind of get to here, that if I were to do the math here, I'd say, well, delta Y equals VIT plus 1/2 AT squared, starting with that. Negative 1.5 equal, I know that's going to 0. I know that's going to be negative 4.9 T squared because that's 0.5 and 9.8. Done this so many times now, right? And so T squared will be negative 1.5 divided by negative 4.9. And so T squared is equal to 0.3 seconds. And so T would equal to 0.55 seconds. Okay? And so the 0.55 seconds for this guy, T is 0.55 seconds here, T is 0.55 seconds there, and T is 0.55 seconds here. And so the key thing to understand is the time is the same. That means these will all hit the ground at the same time. He'll probably fall somewhere here, and then he'll probably just drop right there. They'll have different delta X's, but they will all have the same delta Y and the same T, right? Because that's all being governed here. And of course, VF depends on that time. the y direction. And of course, we could even have found it just using these if we wanted to. We could still work it out without finding the time. All right, so now you can see that my delta x1 is going to be 5 meters per second times 0.55. My delta x2 is going to be 2 meters per second times 0.55. And my delta x3 is going to be 0 meters because it's going to fall right down there. Okay? And so if you were looking at the distance that is increasing or decreasing by, you'd basically find that we have a relationship here where the t is equal to the square root of 2 times delta y over g. You know, all I did was take the delta y equals 1/2 gt squared and kind of solve for t to get this, okay? G is again the same thing as a, so you could just write a over here, but g again is always going to be 9.8. And so that's going to be our t. The two negative signs, the delta y and the g's negative sign, have canceled out, so we don't need to write them. So if you look, the relationship between the height goes as some constant, this is a constant, times t squared. I just put a constant or proportional to, okay, to t squared. So the change in y is going to go by the square of time. If time is increased from 1 to 2 seconds, the delta y will go from a factor of 1 to 4. If time changes from 1 to 3 seconds, delta y will go from this to 9. And it'd be 9 times more than it was during the first time. And so you can see that the delta y rapidly grows, which is why the y velocity function, if you want to look at the arc of it, for example, the velocity in the y direction starts off as being 0 and then getting more and more negative, while the velocity of the x direction remains constant. I'm making VT graphs here. And so, of course, you know that the displacement depends on the square of the rectangle, so it depends on the base and the heights as they increase, which again is related to how the time increases both of these things. It goes by the square because we have an area involved here. Okay, so the key thing I want you to remember is that no matter what speed they come off it, they all hit the ground at the same time. They might hit in different places, but they hit the ground at the same time.